Good morning. My name is Denise Robider from Windsor Forest High School. I am an Algebra 1 teacher, and today I'm going to show you how to factor quadratic trinomials. So before we talk about factoring trinomials, I sort of want to review what quadratics are. Quadratic functions, that is. So back in 8th grade, you learned about what functions are. Functions are relations in which each input has exactly one output. So that's what we're going to talk about here. If you look at this graph or this sheet, it kind of gives you an idea of everything that we deal with functions. 8th grade math introduced the notion of function in an expression using a table of values, and then finally graphing a function. Well, now we're going to go to quadratic functions. Quadratic functions we discussed briefly in a previous unit where we said that the exponent of the variable is 2. So anytime we have a variable that's being squared, we're dealing with the quadratic function. So when you graph a quadratic function, what you're going to get is a parabola. Notice each of these is a U-shaped curve, but there are special points about them. This one here is the vertex. Notice that each of my problems has a vertex in it as well. The vertex is the maximum value or the minimum value of a function. So every single one of these, you see that happening. Another thing you'll notice is that the shape of the U is symmetric along a vertical line. And if you look at the vertical line, you will notice that we have the same point here on the left side just being reflected on this line. This line is called the Axis of Symmetry. So if I know this point, that's 1 unit to the right of the Axis of Symmetry, I get this point that is 1 unit to the left of the Axis of Symmetry. I tell my students, well, I did this for my advanced math students, once you know one point on the right side, you sort of get this point for free. We call this a BOGO point. So if I know this point is 2 units to the right of the Axis of Symmetry, I get this point for free that's 2 units to the left of the Axis of Symmetry. So the symmetry goes back to whenever we reflected shapes. So it sort of builds on what you learned in previous grades, but now we're adding meaning to it, I guess you would say, with algebra. Now, let's look at this point, or this parabola. Here is my vertex. There are a few things that I will want you to notice. Whenever we move 1 unit to the right of the vertex, where we also look at the point 1 unit above. So moving 1 unit to the right, and then we move 1 unit up. I'm just going to abbreviate here. Now, here's where it gets really fun. From the vertex, we're going to shift 2 units to the right. And then what do we have to do to get up to this point? We have to move up 4 units. If there were room, if we moved 3 units to the right, we would end up having to travel 9 units up. So whatever your horizontal movement is, your vertical movement ends up being the square of that. And you can't see it on this graph, but if we were to move 4 units to the right of the vertex, our next point would occur 16 units above. So that's all the nerdy math stuff that I love to explain to my students. It sort of falls into play here whenever we're dealing with squared values or quadratic functions. So keep those things in mind. This is the answer key, by the way, for this sheet. They do offer a blank. I will share the source with you whenever we're done at the end here. Another sheet I like of theirs, actually I like several. Once you start getting comfortable graphing quadratic functions, you can identify properties. So we can talk about the domain, the range, the intercepts, and whatnot. So keep those things in mind as we go through. So again, here are some answers just to kind of practice, because we always need to be able to practice what it is that we do. Math is one of those subjects where you learn best by doing the work. So I tell my students, you learn math by doing math. So here we are. Now, this last sheet, I wanted my students to identify zeros. Once you learn about intercepts and domain and range and all that fun stuff, the important stuff deals with finding zeros of a function. So if you notice here, I've got a 0 at -2, and then another 0 occurs at x equals 1. The zeros are where we touch the x-axis. Why do they call them zeros? Well, think about it. This order pair is -2, 0. This order pair is 1, 0. So we call these the zeros because that's where the y-coordinate is 0. So keep that in mind. That's going to help us with what we're going to do next. And that's sort of the focus of today's lesson. All right, so I like to call myself a T-Rex when it comes to technology because I'm a little slow on what's going on. So what I'm going to do here is kind of do a few things by hand. So that's what I've done here. I've graphed a parabola, and you can see the parabola here. Now, the zeros of this parabola are 1 and 4. We just talked to 1 and 3. So I'm going to make a little notation here, okay? My zeros are 1 and 3. And so I want to be able to build a function knowing that my zeros are 1 and 3. Now you'll have to take my word for this. If the zeros are 1 and 3, the factors are going to be x minus 1 and x minus 3. I'm going to use parentheses here just to set those numbers apart. So now I want to build a function that has factors of x minus 1 and x minus 3. Well, the definition of a factor is a number that multiplies to make another number. So if I want to build a function based on these two factors, all I have to do really is just multiply these two. So once we do that, I want to clean this up. I don't want to have any parentheses. In algebra, whenever we talk about simplifying a function, we want to make sure that we have no parentheses involved and that we're able to just jump right in and give you a function. So that's what I'm going to do now. So there are two methods to multiplying a binomial, as you recall. I'm going to show you the FOIL method, and then for those that don't like it, we'll use the rectangular array, or the box method, as I like to call it. Jane Barnard would tell me not to call it the box method, but that's sort of what I'm used to. So we're going to FOIL these two numbers. X times x is x squared. X times -3 is -3x. -1 times x is -x. And then -1 times 3 is 3. You'll notice here that we have like terms. So when we combine those like terms, we have x squared minus 4x plus 3. So that's what this function looks like. So for those that want to look at the array, I'll put that right here. So we're going to take x minus 1 here. And to lead the rows over here, we'll take x minus 3. So when we take x times x, we're going to get x squared. When we take x times -1, we get -x. When we take -3 times x, we get -3x. And then -3 times 1 is a positive 3. If we have any like terms, they would occur in the diagonal. So when we combine our like terms, we have x squared. When we combine these like terms, we get -4x. And then we bring down our last entry of plus 3. And oh my gosh, look at that. It's just like what we got here. So you choose the method with which you're most comfortable. For this next one, I'm going to sort of move a little faster. But I just wanted to review a few things before we really get deep into the lesson. So if we look at this problem, my zeros are what? My zeros are 4 and 8. So that means that my factors are x minus 4 and x minus 8. And again, I can enclose those in parentheses just to show that they're numbers that are set apart. So when we find this function, it's going to be x minus 4 times x minus 8. So I'm just going to FOIL this. We get x squared minus 8x minus 4x plus 32. My like terms here combine to make negative 12x, and I'm left with 32. So that's sort of an introduction. I do want to show you 2 more examples of this because they will actually help us for when we get to what it is that we need to do. So here, for my next example, I've got some zeros, a zero that ends up being negative. So my zeros here are negative 2 and 2. My factors are x minus negative 2. Uh-oh, that's a new one. And then I've got x minus 2. But please remember, when you're subtracting a negative number, what you're really going to do is you're going to add those numbers together. So my factors are really x plus 2 and x minus 2. So when we build this function, we're going to take x plus 2 times x minus 2. So we take x times x for our first terms. We find the product of our outer terms, the product of our inner terms, and then finally the product of our last terms. These two are opposites. So when we combine those terms, they'll zero out, and we're left with x squared minus 4. And I did plot the points for this one because I want you to see how beautiful this one is. My vertex is here at 0, negative 4. When we move to the right of the vertex, we have to move up 1. 1 squared is 1. From the vertex, when we move 2 units to the right, 2 squared is 4. We move up 4 units to get the next point. And then finally, when we move 3 units to the right, 3 squared is 9. We end up moving up 9 points. And remember, in our axis of symmetry, we get our BOGO points. So we have 1 unit to the left here, 2 to the left here, 3 to the left there. Now, this last one that I'm going to show you really leads into some other stuff. Do you see any zeros? That's a red flag for several people. And I always tell my students, look for red flags and different exceptions to the rules that you're used to seeing. Notice for this example, there are no zeros. So we can't really identify the factors. There are no, I'm going to say there are no obvious factors. That happens in Algebra 1 because in Algebra 1 we're only dealing with the real number system. There are numbers there. My little plug, when you get to Algebra 2, you'll learn them, and oh my goodness, they're so much fun, you'll love it. But there are no obvious factors. And because there are no obvious factors, we're going to say this one is not factorable because you can't make factors if you don't know the zeros. All right, so that leads me into the focus of what I want to go over today. All right, so I want to talk about working backwards. I tell my students all the time that whenever you learn math forwards and backwards. And that's what the case is for today. So we just talked about how to build a function, knowing the zeros. Then you learn then you identify the factors. From there, you can make the zeros. Well, now we're going to actually work backwards from that. I'm going to give you the function, and then I want you to identify the factors. We'll deal with factors today and not get into zeros. That actually opens up a whole nother can of worms. We'll save that for another day. But here are the things that you need to know. Notice here, and I hope I didn't point them out on the previous examples, but I guess I should have. Notice that when you add 5x to 3x, you see the 3 here and you see the 5 here. So this middle term has a coefficient of 3 plus 5. The last term you see here in the trinomial was the result of multiplying the last two terms. So this is 3 times 5. So that's what's going to happen in every single one of these. So you'll notice that to work backwards from this, I kind of sort of explain everything to you here, but I really want to get into how to work the problem. So I can tell you where to find these notes as well. So we want to start factoring a trinomial. This is what we want to factor. We want to look at x squared plus bx plus c. That's our focus here. Here's what you're going to do. You're going to identify the factors of the constant, okay? So I need to find two numbers that multiply to make c. But those two numbers have to be able to add to make the number that's the coefficient of x, or b. And so first thing we're going to do is we're going to find a product of two numbers, and they have to make a special sum. So a lot of teachers refer to this as the product sum method. So once you identify the two numbers that make the product, then you identify the two numbers that make the sum. You're going to write the two binomial factors of the trinomial. That's a whole lot of explanation. I think I just want to jump right into a problem so that you can see it into play. All right. So I need to find two numbers that multiply to 20, but at the same time, those two numbers have to add to 9. So hopefully you would identify those as 4 and 5. So the two numbers are 4 and 5. So that means we're going to write this as x plus 4 times x plus 5. And that's my final answer. Now, you do notice here, I go through all the steps, but the last step, it's a big one. And I even put it in bold because you remember the old phrase, check yourself before you wreck yourself. Check your math, always. So if I were to FOIL this out, I get x squared plus 5x plus 4x plus 20, which is x squared plus 9x plus 20. You could do the work off to the side, or you can take my word for it. But I always encourage my students to not take my word, because I'm wrong sometimes. We're all wrong every now and then, and you just need to check. All right, look at number 2. So I need to find two numbers that have a product of 12, but at the same time, they have a sum of 7. So what are two numbers that multiply to make 12, but at the same time, they add to make 7? 3 and 4. So we're going to factor this as x plus 3 times x plus 4. And then we check it. X squared plus 4x plus 3x, there's your 7x, and then 3 times 4 is 12, so it checks. So everything's going along swimmingly. Usually my students are loving this. They're going along great until we see negatives. And then time stops for the briefest minute. So let's look at this one. I need to find two numbers that multiply to negative 12, but at the same time, they add to 4. So at this point, I like to make a table. Sometimes that helps me figure these out. So let's look for two numbers that have a product of negative 12, but at the same time, they have a sum of 4. And I'm going to put a positive 4 there. Okay, so let's go easy. Let's not throw any signs on anything. Let's just make a list. Numbers that multiply to make 12. We've got 1 and 12. We've got 2 and 6. We've got 3 and 4. Slow your roll, Robider. One of them has to be negative. And the reason one of them has to be negative is because if you multiply two positive numbers, you get a positive sum. A positive product, I beg your pardon. You multiply positive 2 times positive 6, that's positive 12. Same thing applies here. So in order to have a negative product, one of the factors must be negative. So I can either have a positive 1 with a negative 12, which gives me a sum of negative 11, because remember, the larger sign is the one that you need to figure out the sum. So we probably should make the larger number positive, and let's make the smaller number negative. So when we add negative 12, when we add negative 1 to 12, we get 11. When we add negative 2 to 6, we get 4. Ding, ding, ding. That's the combination that I'm looking for. This is +1 for those of you playing at home. So the two numbers I need that have a product of negative 12 and a sum of 4 are negative 2 and positive 6. So this is going to factor to be x minus 2 times x plus 6. So when we look at number 4, we need a product of negative 35, and then we need a sum of negative 2. So my product is negative 35. My sum is negative 2. What are those two numbers? Well, I know 5 and 7 subtract to make 2. Okay, but you said that the sum has to be 2. Well, whenever we're dealing with opposite numbers, how do you find the sum? You subtract them. So 5 and 7, when you add them as negatives, you get 2. But you see how the sum is negative? So that means that the 7 has to be the negative number. So this is going to factor to x plus 5 times x minus 7. So everything's fine. You're getting comfortable with positive products, negative products, product and sum. And then you get to a problem like number 5, and suddenly I don't have a number in front of x. I know my product is negative 30, but what's my sum going to be? Remember, there's an invisible 1 here, an understood 1. So we're going to have a sum of 1. I see that my product is negative, so that means that the two numbers I use are going to have opposite signs, because when you multiply opposite signs, that's when you get a negative product. So which two numbers multiply to 30 but subtract to make 1? 5 and 6. Now, my sum is a positive 1, so that means that 6 has to have the positive sign. That forces 5 to have the negative. So this is going to be x minus 5 times x plus 6. All right, so now we look at a problem like number 6. I've got a positive product of 6, but suddenly I've got a sum of negative 5. So how in the world am I going to have a positive product but a negative sum? Well, that happens whenever your numbers are the same sign. So to have a product of positive 6 and at the same time to have a sum of negative 5, that means both of these numbers have to be negative. Oh, that adds to negative 7. So now let's try 2 and 3. That adds to -5. Ding, ding, ding. There's our winner. So what that means is my two numbers are going to be -2 and -3. So my factorization will be x minus 2 times x minus 3. And again, you're checking these as we go. For the sake of time, I'm not. Now, a lot of people are often confused. They don't remember how to find products. So remember these nice little composition books that you're all required to get and you never use them? Well, if you look in the back, there's always a multiplication table. So the multiplication table can help you find your products, but you've got to remember your integers. But I don't remember my integers, and that's okay. If you don't remember integers, you suddenly have a little bit of free time where you can practice integers, I believe. So keep those things in mind. We do get a little more involved here whenever we're using different variables or more than one variable. That's okay. You're just going to do these like you've done everything else. So let's skip to number 8, shall we? I'm still looking at a product of 18. So my product here is 18. My sum is 11. So what two numbers multiply to 18, but at the same time add to 11? 9 and 2. So this is going to factor as x plus 9 x plus 2. I left some room there. Why do you think I would leave the room? Because I've got another variable involved. And so that variable will go there on the second half of the binomial. Let's check it, just because we're doing something different. This becomes x squared plus 18xy, I beg your pardon, 2xy plus 9xy plus 18y squared. Here are my like terms, messed up as they are. We get x squared plus 11xy plus 18y squared. And that's what matches here. Okay, so let's look at another. Man, I'm going to throw you curveballs left and right, so I hope you're ready. Let's look here. My product is 20. My sum is -8. So I need two numbers that multiply to 20, but at the same time, they add to -8. So let's look at our list. My product is 20. My sum is -8. Both numbers have to be negative, because when you add negative numbers, that's when you get a negative sum. So let's look at -1 and -20, -2 and -10, -4 and -5. The sum here is -21. The sum here is -12. The sum here is -9. There are no other factor pairs that multiply to 20 and add to -8. So that means this is not factorable. I feel like I heard that word maybe 20-something minutes ago. And we did. Remember this graph? We didn't have a 0 on here, so we had no factors, and we called this not factorable. I bet if we wanted to graph this, we would see that at no point do we touch the x or the c-axis. Well, there's another axis involved too, but that's an Algebra 2 issue you'll have to deal with. So keep things like this in mind. So whenever we're factoring, what we're looking for are the places where each of these quadratics touch the x-axis, where the y value equals 0. So that's what we're leading into here. And again, I gave a lot of explanation, but the best way to do these problems, to learn these problems, is to do them. You learn the math by doing the math. And then they get a little uglier, but we actually will save that for another day. What I want to do now is show you some of the resources that I've used, because we all are looking for resources right now, parents and teachers alike. So if you look at my first site, it's called Math Worksheets for Kids. I did ask them for permission to post some of their information on my Weebly page or on my Google Classroom. They allow me to use their links because they want teachers and parents to use them as resources. So you'll see here, what I'm doing is if I go to Math Worksheets for Kids, even though it's called Math Worksheets for Kids, they've expanded to language arts, science, social studies, but being a math teacher, let me look at the math. So here are all of your options for math. What I want to look at is algebra. And the sheets that I showed you are here under functions. Here is the function table sheet that I gave you. And you'll see once you select something, they give you all the options. They show you which ones are free. And then they have some that you can download if you are a member. But I like the free worksheets. So you can see all the different options here. So if I look at a function table and look at the free sheet, it gives me a blank in which to practice, but they always are kind enough to show the answer key. When you start to learn some of this material, you think, okay, those are simple. There are only 6 of them. I really want to do more. So the other software that I like is CudaSoftware.com. And they have algebra. They have pre-algebra, algebra 1, geometry. Again, I want to look at the free worksheets for algebra 1. And here they are. You've got your basics, your equations. Those of you that still need help with solving equations, look at all these resources they have. The basics where you're dealing with adding and subtracting rational numbers, code word fractions. Keep stuff like that in mind. When we get to quadratic functions, we have several different options here where you can factor. Oh, here's where we want to go. I apologize. Polynomials, naming them, adding, multiplying. Then we talk about factoring. I want to factor quadratic polynomials. How kind are they to give you easy problems, and then they give you hard problems? So when we go to the easy problems, they start again with a equals 1. These are the ones that I called product sum. And here they are. They give you 26 of them. Did you do them right? Well, you can FOIL, or you can look at the answer key. And they also give examples that are not factorable. So those are some resources to get you through for the next few weeks. And we may do this again soon. Thank you so much.